Hey Ninja Warriors, welcome to yet another power packed session, and in today's session we are going to talk about differential equations from the very scratch to the JEE main and advanced level, okay? But I have a disclaimer for you. You can just take it as a warning as well, that without a few chapters differential equation cannot be mastered. What are those prerequisite chapters for differential equation? First thing. Second thing, I'm going to talk about the weightage of this particular chapter as far as your JEE Main 2025 or 2026 is concerned. So yes, let me talk about first of all the prerequisite chapter. So prerequisite chapter of differential equation will be obviously indefinite integration, okay? So basics of indefinite integration you should know, first thing. Second thing, you should be aware about the differentiation of standard function. So derivative of standard function is something that you should understand, you should know standard function. And yes, if you are aware about specifically these two things, then your differential equation journey will be smooth. But if you think that you have not studied anything about indefinite integration and differentiation, then differential equation will be a difficult task to do. So I will highly recommend that go back. I have covered indefinite integration and method of differentiation, both chapters in this roar series. Go back, watch that lecture, come back. Okay. Next thing I'm going to talk about is weightage of differential equation. Weightage of differential equation. So in every shift, you just go pick any JEE main question paper in 2024, in 2023, in 2022. Weightage of differential equation will be how many questions they have asked from this chapter. 2 questions alone they have asked from this chapter. So from differential equation, you can expect 2 questions from this chapter, okay? Alright, now let us just start studying this chapter. Let's just start understanding. So first of all, what are differential equations? Let me write a few examples for you guys to understand that, okay, these are something which we called as a differential equation, okay? Alright, so first, so I'm going to write a few differential equations, sample differential equations you can say. So d2y upon dx square plus 3 dy by dx plus 2y is equals to 0 is a differential equation. Why? What is this having? So can you see that multiple orders of differential equation you can see over here, multiple order derivatives you can see over here. d2y by dx square, that means you have differentiated y with respect to x twice, differentiated y with respect to x 1, and differentiated, like not differentiated, just 2y equals to 0. So this is of the type polynomial, right? Why I'm saying polynomial? Because you just observe that the powers are whole number. Power of the derivatives can never be negative, can never be whole number. So if I say that dy by dx has power 2 by 3, now is this a differential equation? No, a big no. Okay, right now in this format. So understand that the format should be of the type polynomial. Let me give you more example for better understanding. d2y by dx square equals to y plus dy by dx power 6 raised to power 1 by 4. Now understand, is this a differential equation? Right now, I don't think so, but it could be a differential equation that we need to analyze. So this is 2, this is 3, right? Okay. So, sorry, this is 2, so 3 by 2. Now the power is 3 by 2. Now, what I can do is, now I can just square both the sides, right? So if I square both the sides, this 2 will get cancelled out, this 2 will appear over here. Now this looks like a differential equation because it doesn't have any negative power, it doesn't have any fractional power. All the powers of differential coefficients or derivatives are whole number. Okay, fine. Third is y square equals to x square plus 2xy dy by dx. Again, simple. Fourth is d2y by dx square equals to x square plus 2xy dy by dx. Okay, so these are the examples of types, like different variety of differential equation. Okay, let us dive a little bit more about differential equation. Let us talk about two very important terms in differential equation, which are order and degree of differential equation, guys. Okay, so what is order? First of all, let's talk about the order, because to understand degree, to know the degree, you have to know the order first. Once order is calculated, now then only you can talk about the degree. Okay, are you getting my point? So order is highest differential coefficient. Highest differential coefficient. Okay, highest differential coefficient. Now what is, ma'am, differential coefficient? Okay, so basically differential coefficient is what? dy by dx is a differential coefficient. d2y by dx square is a differential coefficient. d3y by dx cube is a differential coefficient, and so on. So the highest one will be the order. Okay, but in finding the order of differential equation, to find the order of differential equation, you have to understand, first of all, make sure that your differential equation is in proper format. That means it is of the format of the polynomial. Let me show you. Let me give you one example. For example, first, d2y by dx square equals to y plus dy by dx power 6 raised to power 4. Now, at this moment, you won't be able to calculate order, although it is clear that the highest differential coefficient is 2, but the recommendation is, first of all, let's just properly convert it into normal, like polynomial form. So this is 3 by 2. Now again, this is the copy pasted equation. Now this 2 will be gone and this is square. So order of this is 2, clearly, because not because of this 2, because of this 2, because your y is differentiated twice. Okay, order is clear, right? Second one will be dy by dx plus y equals to 1 upon dy by dx. Now clearly that y is differentiated 1, dy by dx. Order would be 1, but don't do that, because can you see here, actually this is what? Dy by dx reciprocal means what? That it is having negative power of dy by dx. That means right now it is not in the proper form. So to convert it in proper form, you just have to multiply dy by dx on the left hand side. So it is going to become dy by dx whole square plus y dy by dx equals to 1. Are you getting my point? Yes, now you can say yes, order is 1. Okay, ma'am. Now let's talk about the next thing, which is next thing, e raised to power d3y by dx cube minus x d2y by dx square plus y equals to 0. Alright, so if you just see this thing over here, you'll be like, ma'am, order is 3. Order of this differential equation is 3. Okay, so yes, order of this differential equation is clearly 3. Next, let us move on. Next is ln dy by dx equals to ax plus by. Now again, order of this would be 1, correct? Now one more thing, what I will be doing is, this is log of dy by dx. Understand, in both these differential equations, I'm just making you observe things. The differential coefficient is inside another function. Can you see that d3y by dx cube is a argument, or you can say input of exponential function. dy by dx is input of logarithmic function. I'm just letting you know. Okay, we'll talk about it later, what is the thing, but order we can calculate. Then here 1 plus 3 dy by dx power 2 by 3 equals to 4 d3y by dx cube. Again, order of this is obviously 3, But to convert it into proper format, you have to cube both the sides. 1 plus 3 dy by dx power 2 is equals to 4 d3y by dx cube, and this is cube. So that is why, because of this third differential coefficient, order is 3. Now you must be wondering, ma'am, order we knew, order we understood. What about degree of the differential equation? Now let's start understanding the degree part of the differential equation. So clearly, if I talk about the first equation, now degree, ma'am, what is degree? So degree is nothing but, let me just give you this definition. Degree of differential equation is power of highest coefficient. Basically, power of highest differential coefficient. Okay. So in here, what is highest differential coefficient? That means, like, by noticing which differential coefficient you have written the order, obviously this is like 2, order is 2. Now the power of this thing is what? Power of this thing is 2, so that is why degree is 2. Hold on. Okay, let us talk about the next question, you will understand. Now can you see that order of this is dy by dx, so 1, order is 1 clearly. Now degree is nothing but basically highest power of highest differential coefficient. So highest differential coefficient is 1, basically dy by dx power 1 or dy by dx power 2. Now the power of dy by dx will be your degree, and that too highest one, so power 2 will be selected, that is why degree is 2. One more question, one more. Now in this case, there is a catch. Now understand, your third differential coefficient or any differential coefficient for that matter cannot be inside any function. So here, because the third differential coefficient is inside the exponential function, the degree will be not defined. If you are able to free this d3y by dx cube, then it's fine by taking log or by any manipulation. But if you try, okay, so what we can do is we can just try to make this thing free from exponential. So how to do that? E raised to power y3, suppose this is y3 is equals to x y2 minus y, correct? Now you take log both the sides. But even if you take log both the sides, what will happen is y3 will get freedom. But now the right hand side, this is log x y2 minus y. Now this differential coefficient y2 is again a differential coefficient that will get stuck inside another function. So again, that's a big trouble. So the condition of degree to be defined properly, your any differential coefficient cannot be input of any function. Okay, are you getting my point? Just like this. Now in this case, you can say that degree is, ma'am, not defined, but if I take anti-log both the sides, what will happen? Anti-log of this will give you dy by dx, and this will be e power ax plus by. Now this time, can you see differential coefficient we have freed the differential coefficient, and even if I have taken exponential on the right hand side, there is no differential coefficient which is stuck inside exponential function. So here, now this time degree equals to 1. One more question. So here again, can you see order is 3 because of third differential coefficient? Now the power of third differential coefficient is 3. That is why degree is 3. Okay. Alright. So I guess order and degree concepts are clear to you now. Okay. Now let us talk about something which we wanna call it as formation of differential equation. Formation of differential equation. Okay. Formation of differential equation. Okay. Now suppose you are given with a family of curves. Family of curves means that it could be like pair of straight lines, it could be family of circles, right? And if you differentiate the family of curves, what you're going to get is differential equation, of course. Okay. If you want to integrate the differential equation, what you're going to get is family of curves. Suppose y equals to mx. This is what? Family of straight lines, right? Which is, if you change m, you will get different set of lines. Now if you differentiate this, dy by dx equals to m, and form a differential equation, now this m will be replaced by, so y is equals to dy by dx into x, or you can call it as dy by dx equals to y by x. Now this differential equation you are getting once you have differentiated your family of curves, and if you integrate this, what you are going to get is back to y is equals to mx. So that is the relation, basically the importance or significance of differential equation, where exactly differential equation is coming from, the birth of differential equation, right? Okay, here m is something which we called as arbitrary constant. Okay, all right. Now what is this? Now one more important fact I just want to let you know, which is very important, by the way, guys, that okay, so suppose if you're saying, ma'am, this is differential equation, can anybody tell me what is the order of this differential equation? Order is 1. So understand that if your family of curve, now understand this nicely, if your family of curve is having one arbitrary constant, then the order of differential equation will also be 1. Let me write this down for you. If family of curve is having one arbitrary, or you can say n arbitrary constant, then order of differential equation of that family of curve will also be n. Basically order is equals to, so basically order of differential equation is equals to number of arbitrary constants. Are you getting my point? All right. Okay. Now a few points related to differential equation. Now each curve will have its own differential equation. Okay, so suppose a curve is given to you, it will have its own unique differential equation, guys. Unique differential equation. So curve is related to a unique differential equation. That is first point. Okay. Second point is like order is of differential equation is number of arbitrary constant. I already told you. Now one more point, that differential equation, or you can say the final differential equation, will not have any constant, will not have any arbitrary constant. Okay, so now let me just give you one problem, guys, regarding the order of differential equation. So I just want you to tell me, if I give you a curve y equals to c1 plus c2 cos c plus c3 minus c4 e raised to power x plus c5, correct? Where c1, c2, c3, c4, c5 are arbitrary constants. Okay, and you're looking for order of differential equation of given curve is what? Options are 5, 4, 3 and 2. Now understand, they are talking about order of a differential equation. Now for that, one way is to differentiate this, find the differential equation, and then after that, once you get the differential equation, you just give the number of order, basically the order of that differential equation. Okay, but we are not going to go in that way, because we know that the number of arbitrary constant is equals to order of the differential equation. Now, a few people will say, okay, 5 arbitrary constant. So 5 will be the answer. But 5 is not the answer, because you understand that you have to eliminate the unnecessary constants. Here C1 plus C2 can be replaced by one single constant. Yes or no? So y will be equals to k cos. Now again C plus C3. So this is k1. C plus C3 will be k2 minus, now one more thing, C4 e raised to power x e raised to power C5. One more thing, okay, there is one more reduction, guys. This C4 into e raised to power C5, if you just multiply these two together, that will become minus K3 e raised to power x. So now only 3 constants are left and we cannot further reduce them. So that's why the order of this differential equation is not 5, not 4, but 3. Are you understanding this? Are you getting this? Okay. All right. Now, one more question on your plate. So question says that you are given with a curve. A curve is given. Curve y square equals to 4a x plus a. Correct? This is given to you. And now, what you have to do is you have to figure out the differential equation. Options are y dy by dx whole square minus 2x dy by dx is equal minus y equals to 0. Option B is y dy by dx whole square minus 2x dy by dx plus y equals to 0. Option C will be y dy by dx whole square plus 2x dy by dx minus y equals to 0. Okay, and option D is y dy by dx plus 2x dy by dx minus y equals to 0. Okay, so let's just try finding the actual exact differential equation. How to find a differential equation? Let me just show you. Let me give you an idea. So yes, can you see there is one constant. A is one constant. So just keep that in mind. You just have to differentiate your curve only once, not more than once, because you have one constant. You have to differentiate it once. You will get dy by dx. No further differentiation, because if you differentiate it second time, you will get d2y by dx square. You don't want that because your order is 1, right? So only once. Okay. So 2y dy by dx equals to 4a is constant and this is 1. So now your basically, okay. So from here, can you see your a is coming out? 4a is what? So 4a will be 2y y1. That is first equation. But what about the value of a? So value of a from here is y y1 by 2. Are you getting it? Now just plug in the value of a over here in this equation. Let's do that. Okay. So now let me just give you this. Okay. So this is y square is equals to 4a. Right. Now 4a can be replaced by 2y y1. And this is x plus y y1 by 2. Correct? Y, now one more thing. Y and y is getting cancelled out. Y is equals to 2 y1x plus, this is going to be 2 cancel. So this is y y1 square. Correct? So now this is it. Now if you shift this y on the right hand side, you will get y y1 square minus 2y plus 2 y1x minus y equals to 0. So y y1 square plus 2 y1 x. So can you see this is actually matching with option C, guys? Right? So option C is absolutely right. Okay. Correct or not? Option C is absolutely right. Okay. Clear? Shall I move on to the next problem now? Okay. So the next problem is like this. Question says, the difference between the difference between degree and order of differential equation that represents the family of curves given by y square equals to a x plus root a by 2, where a is greater than 0. Okay, so difference between degree and order of a differential equation that represents the family of curves given by. So order is clearly 1 because the number of constant is 1, so order is 1. Now what about degree? To get the degree, we have to differentiate this one, find out what is the degree. Let's do that. Solution. 2y dash equals to a is constant. This is 1 plus 0, correct? So now your a is coming out as 2y dash, that's it. 2y1 or 2y dash, one same thing. Now you have to plug in the value of a, constant a, in your curve. So let me just put this. Y square is equals to 2y1 x plus root a by 2. So root 2y1 by 2, correct? Got it? Now one thing, y and y are getting cancelled out over here. So y is getting cancelled out with this, and you are getting y is equals to 2y1 x plus, now multiply it inside, root 2 2y1, and y1 will be kept outside just like this. Okay, hold on. Now you know that square root is not allowed. You can't find out degree right here. For degree it is very strict. For order you can still find it, but for degree you have to make sure that there is no fractional power. So power of this y1 is what? dy by dx. Power of dy by dx cannot be half. So what you need to do is, you need to shift this. So y minus 2y1 x equals to y1 square root 2y1. Now square it both sides. Square both the sides. So y minus 2y1 x whole square is equals to y1 square and 2y1. Okay. Alright. So can you see that on the right hand side you are getting y1 cube 2y, and this is y minus 2y1 x whole square. So can you see that order from here is what? y1, highest coefficient order is 1, guys. Okay, but what about degree? Degree will be 3. From here order is 1, degree is 3, and hence you can call it as your final answer is equals to 3 minus 1, that is 2. Okay, degree minus order is 2. Is it correct? Yes. All right. Clear? Okay. Now, let me give you two very important terminologies in differential equation, which is general solution versus, or you can call it as, and particular solution. General solution and particular solution. Okay. So suppose y equals to kx. This is actually a general solution. But y equals to 2x, this is a particular solution. So general means there will be like general. Particular means that there will be no constant left out. Okay. So now, if you solve any differential equation, if you just solve, so basically, if you are given with a differential equation and if you're solving that differential equation, let me show you. Just for example, you are given with dy by dx equals to y by x. Now, if you are supposed to solve this differential equation, that means you have to find out the curve related to this differential equation, right? Cross multiply. So, dy by y is equals to dx by x. Now, integrate. Left side with respect to y, right side with respect to x. So, this is going to be log y is equals to log x plus c, or you can call it as log k, right? So, this is going to be log of y is equals to log of kx. Y will be kx. Are you getting it? Y equals to kx. Okay. So now y equals to kx is something which is called as a general solution. So the moment you solve any differential equation, you will get a general solution, right? But if you put any initial condition, suppose the question says that the curve is passing through 1, 2, then what will you do? After finding general solution, you'll be like, okay, 1, 2. So you can just put 1, 2 over here. So 2 is equals to k and 1. So k is coming out as 2 and you are going to write it as y is equals to 2x. So now can you see this is a particular solution? Okay. So for any differential equation, there will be a lot of questions. You'll be given with observe. Now start observing the questions. You'll be like, okay, this is the differential equation and of the curve, and the curve is passing through this point. So you must be wondering, ma'am, why they are giving that curve is passing through this point? Because they want you to solve it and then put that value to get the particular solution. So initially you will get general, but if you satisfy those conditions, you will get particular solution. Don't worry. We'll do it. Okay. Yes. Now officially we are starting differential equation. Till now we were understanding basics of differential equation, right? Now we are starting differential equation, guys. Are we ready for it? Are we up for it, guys? Okay. All right. So now, how many types are we going to understand in this? Variable, separable. First. Second will be homogeneous differential equation. Homogeneous. And then linear. Okay. And now these are the three types. Now second, third. Now after variable separable, we have another type which is reducible to variable separable. Okay. That means the first form is straightforward. The second form is you do something, you substitute something and then you will get variable separable. Just similar like homogeneous differential equation. So you will get reducible to homogeneous differential equation, linear differential equation, and then reducible to linear differential equation. These 6 forms we are going to tackle one by one. So the whole structure is going to be this. The whole differential equation is going to be this. Variable separable, what is the form? Like how does it look like? How to solve it? Then reducible to variable separable, how does the form look like? How to solve it? Homogeneous differential equation, how does the form look like? How to solve it? Reducible to homogeneous, then linear differentiable, what is the form? How to solve it? Then reducible to linear differentiable, what is the form? How to solve it? Okay. So are we ready for each and every form? One by one we'll be addressing each and every form. Let's start with, by the way, important of all is linear differential equation. Is very important. Okay, so first, form number 1, variable separable. Variable separable. Okay. So again, we have done this actually, dy by dx equals to y by x. So what do we want to know is, what do we do in this? Very simple, it's quite intuitive. One variable on one side, so dy by y because we want y on the left side, x on the right hand side. Now just integrate ln y is equals to ln x plus, don't forget the constant ln c or ln k, y is equals to kx will be the solution. That's it. This is as simple. This is just an example, right? Now let us start doing the real problems. Okay, question time, guys. Let y equals to y of x be solution of differential equation log of, this is log of dy by dx equals to 3x plus 4y. Y of 0 is given as 0 and y of minus 2 by 3 ln 2 is alpha ln 2. Then the value of alpha is something they are asking about. Then the value of alpha is what? And the options are also given to you. Minus 1 by 4, 1 by 4, 2, minus 1 by 2. Okay, all right. Y is equals to yx is the solution of this differential equation. So solution may we have to just solve this differential equation. Now log of dy by dx equals to 3x plus y. Right now we are not in that state where we just separate out the variable. Okay, right now we are not. But if I take anti-logarithm, I can do that. Anti-logarithm, so basically e power 3x plus 4y is going to give you dy by dx, correct? Now the next step would be on the right hand side, watch me, this is a very good question. E raised to power 3x and this is e raised to power 4y. Can I write the right hand side like this? Now I can separate them out. Now I'll be doing it. See, e raised to power 3x and dx can be taken on the right hand side. Pretty easy. But on the right hand side we have dy and this e raised to power 4y will come in denominator, or you can just write e raised to power minus 4y, integrate, and this is also integrate. Okay, now you integrate, like real integrate. E raised to power minus 4y integration, tell me. So e raised to power minus 4y upon minus 4 is equals to, on the right hand side, e raised to power 3x upon 3 plus c. Okay, all right. So this is what you are getting now. So this is just the basic solution, but now they have given some information. Now can you see, they have given y of 0 equals to 0, right? Y of 0 is given out as 0. Y of 0 is 0 means what? Y of 0 is 0. That means 0 comma 0 you can satisfy over here. So the moment you will satisfy 0 comma 0 over here, you will get e raised to power 0 upon minus 4. E raised to power 0 by 3 plus c. Minus 1 by 4 equals to 1 by 3 equals to c. Minus 1 by 4 minus 1 by 3 equals to c. This is going to become minus 7 by 12. Minus 7 by 12 is equals to c, correct? Okay. So now this is your final solution will be e raised to power minus 4y upon minus 4 equals to e raised to power 3x upon 3 minus 7 by 12. This is your final curve, correct? Now up, if I go back, this is your final curve. They are saying y of minus 2 by 3 ln 2. That means in place of x, if you put minus 2 by 3 ln 2, so x is equals to minus 2 by 3 ln 2. What you are going to get is on y you're getting out as alpha ln 2. So you have to satisfy both in this. Let's do that. So e raised to power minus 4, y is what? Alpha ln 2 upon minus 4 is equals to e raised to power 3 minus 2 by 3 ln 2 by 3 minus 7 by 12. Okay. So now this is e raised to power minus 4 alpha ln 2 upon minus 4 is equals to, now 3 cancel, e raised to power minus 2 ln 2 by 3 minus 7 by 12. One by one we'll solve it, okay. So now understand, I'll be applying properties of logarithm over here. This minus 2 will go over here. So this is what? 2 raised to power minus 2. Now 2 raised to power minus 2 is 1 by 4. So this is 1 by 4 into 3, 1 by 12 minus 7 by 12. And what about this again? Minus 4 will go here. So this is going to become 2 raised to power minus 4 alpha. See, e raised to power log of something is that something. See, e raised to power ln x is x only. This is the formula I am trying to apply. So if minus 4 alpha is going on the power of 2, see, minus 4 is going here in the power of 2, correct? So what will happen over here? If minus 4 goes here, then it will become e raised to power ln. E and ln will get cancelled out. So 2 raised to power minus 4 alpha is right here. So yes, now this is minus what? This is coming out as minus 1 by 2, correct? Yes or no? And let's not forget this upon minus 4. Yes. So now what you're getting is 2 raised to power minus 4 alpha upon minus 4 is equals to minus 1 by 2. Minus minus cancel, 2 ones are 2 twos are, 2 raised to power minus 4 alpha is equals to 2 raised to power 1, right? This is alpha. So minus 4 alpha is 1, alpha is minus 1 by 4. So patiently if you solve it, you will get option A as the correct answer. Have a look. Let me know. Let me know. Okay. Clear? All right. One more question. So the question says that let y is equals to y of x be the solution of differential equation e raised to power x square root 1 minus y square dx plus y by x dy equals to 0, where y of 1 is given as minus 1 and they are asking y of 3 whole square is equals to what? Options are also given to you. 1 minus 4e cube, 1 minus 4e power 6, 1 plus 4e cube and 1 plus 4e power 6. Okay. Alright. So now this, understand. This is your expression, right? Again, variable separable, we only know this. Let's start. E raised to power x and dx will stay together and this, see, okay, hold on. E raised to power x 1 minus y square dx is minus y by x dy. Okay. Now this x will go here and this 1 minus y square root will go here. Okay. So this will become e raised to power x dx is equals to minus y upon square root 1 minus y square dy. Yes or no? Okay. So now you have to integrate on both the sides. Now integration is not that difficult. By parts we are going to apply Eilert rule. First function, second function. First function constant, integration of second function minus integral of derivative of first. So derivative of x is 1. E raised to power x dx is equals to now this. Now this. In here what I'm going to do is 1 minus y square we are going to substitute as t square. So this is going to become what? Minus 2y dy is equals to 2t dt. Correct? 2 to cancel. So minus y dy is going to become t dt upon this is again square root t square is t. So integral of dt is what? T. So now this is going to become x e raised to power x minus e raised to power x equals to integral of dt is what? T. So this is t plus constant. Now t is what? So finally you are going to get x e raised to power x minus e raised to power x equals to 1 minus y square root plus c. Okay, and now so you're getting this. The final thing is this, understanding it. Now can you see y of 1 is minus 1, that means you put x equals to 1, you will get y equals to minus 1. Let's do that. Put x equals to 1, so this is going to become 1 e power 1 minus e power 1. You will get y equals to minus 1, so this is square root of 1 minus 1 plus c. So this is 0 equals to c. Constant is coming out as 0, guys. Constant is coming out as 0. Okay. So this constant is gone. So finally your differential equation is x e power x minus e power x equals to square root 1 minus y square. And put x equals to 3. You will get this. So put x equals to 3. 3 e power 3 minus e power 3 is equals to, so this is square root 1 minus y square. Now this is 2e cube is equals to 1 minus y square whole square. So this is gonna be 1 minus, so y will be what? Tell me. Sorry, y square from here will be what? So y square will be equals to 1 minus 4 e power 6. This is your final answer. Y square is 1 minus 4 e power 6. Option B is absolutely correct. Okay. All right. Let me know if it is clear. Okay. So now we are done with variable separable. We'll start with reducible to variable separable. Reducible to variable separable. You need a lot of patience in listening to a lecture. I know that you guys are having very minimal attention span. But it is what it is. It is what it is. Okay. Reducible to variable separable. So a differential equation of the type dy by dx is a function of linear expression in two variable, or you can say, I to call it as function of a straight line. So whenever you see dy by dx is a function of straight line, then what to do? Put that straight line is equals to t and you will be done. Let me give you one example. Directly we are going to do one question which was asked in JEE Main 2019. Okay. So the question says, okay, that dy by dx, solution of dy by dx, so solution of this differential equation, which is dy by dx is equals to x minus y whole square, where y of 1 is given as 1, is, options are log of 2 minus x upon 2 minus y is equals to x minus y. Option B is log of 1 minus x plus y upon 1 plus x minus y is equals to x minus y. Option C is minus log of 1 minus x plus y upon 1 plus x minus y equals to 2x minus 1. And option D is minus log of 1 plus x minus y upon 1 minus x plus y equals to x plus y minus 2. Okay. So these are the options, all 4 options. Hold on. I have given you incorrect options. So this is 2x minus 1. Option C is, hold on. Option C is looking like minus log, okay. minus log c, right? Minus log 1 plus x minus y upon 1 minus x plus y and x plus y minus 2, and last option D is log of 2 minus y upon 2 minus x is equals to 2 of y minus 1. Okay, this was asked in JEE Main 2019. So again, can you see solution? Can you see this? dy by dx, can you see, is function of x minus y. X minus y is a straight line or a linear function. So now dy by dx, since we can see dy by dx is x minus y whole square, here x minus y will be equals to t. Okay, x minus y will be equal to t. Now if you differentiate this, it is going to become 1. So if you have substituted this as t, now differentiate it. 1 minus, or you can say that 1 minus dy by dx is equals to dt by dx. So you have differentiated this whole thing, x minus y equals to t, with respect to x, differentiated with respect to x. Okay, so now your differential equation will become what? So dy by dx will be replaced by 1 minus dt by dx from here, using this, is equals to x minus y is what? T square. So now understand, this is 1 minus t square is equals to dt upon dx. Okay, all right, and now dt upon 1 minus t square will be equal to dx. Now integrate. So now you know the formula. How many of you know? 1 upon a square minus x square integral is what? Log of a plus x upon a minus x plus c. This is the formula which I am going to use. So this is log of 1 minus t upon, 1 plus t upon 1 minus t is equals to x plus c. Now put the value. Log of mod of 1 plus t is what? T is x minus y. 1 plus, this is 1 minus x plus y is equals to x plus c. And now, because the initial condition is given 1 comma 1, satisfy 1 comma 1. So log of, satisfy 1 comma 1. So this is 1 upon, this is 1 is equals to 1 plus c. Clearly c is coming out as minus 1. So this is minus 1. So this is also minus 1. So basically your answer would be what? This is 1 by 2a. So this is 1 by 2. Let's not forget 1 by 2, right? 1 by 2. So c is minus 1. So your answer will be what? This is your answer. So this 2 will go over here on the right side, twice of x minus 1. So option B is absolutely right. Can you see option B is correct? Yes? Understanding it? Okay, so this was reducible to variable separable. But there is one more special type in reducible to variable and separable, which is a special type. I can call it as type 2. Reducible to variable separable. Reducible to variable separable. Okay, all right. So now dy by dx is equals to a1x plus b1y plus c1 upon a2x plus b2y plus c2. So basically dy by dx on the right hand side you can see is a function of two different straight lines. Okay, but it has to be a specific condition, which is sum of b1 and a2 should be 0. a2 plus b1 is equals to 0. If at all this is 0, then this will become reducible to variable separable, otherwise not. It can't be random two different linear expressions. No. If they are two random linear expressions, then they will be tackled in a different manner. If they are two random linear expressions, but if b1 and a2 sum becomes 0, then this is going to become reducible to variable separable. Let me show you how to do it. See, dy by dx is equals to x minus 2y, x minus 2y plus 5. This is a very specific case. 2x plus 3y minus 1. Now can you see that right here minus 2y and plus 2x are becoming 0, minus 2 plus 2 coefficients. Then if it is happening, then what to do? Cross multiply. Cross multiply. You have to cross multiply. The trick is to cross multiply. So let's just cross multiply. I'll show you how to do it. So dy, this is going to become 2x dy, correct? Plus 3y dy minus dy is equals to x dx minus 2y dx plus 5 dx. Now understand, very important. Minus 2y dx, where is that minus 2y dx? So this is and this. These two be clubbed together because see, a2 and b1, we were focusing on a2 and b1. So that means a2x, basically 2x dy and minus 2y dx, they should be together. I'll tell you what, 2x dy plus 2y dx. Now rest everything should be taken on the right hand side. This is going to become 3y dy and so 3y dy plus negative 3y dy plus dy plus x dx were already there plus 5 dx. Okay, alright, so now what is this? 2x dy. Don't you think that x dy, don't you think somebody has kept x constant and differentiated y, plus somebody has kept y constant and differentiated x, right? So if I just take 2 common, so this is going to become x dy plus y dx. See, x dy plus y dx is nothing but derivative of xy. How will you differentiate xy? Tell me. So product of two functions, you keep x constant, differentiate y, you keep y constant, differentiate x. So this is 2 dxy you can keep. This is again same thing, right? Same as it is. Now integrate. Start integrating. Integrate both the sides. So now what will you get if you integrate? You will get 2. Now integration of dxy is 2xy is equals to, this is going to be minus 3 y square by 2 plus y plus x square by 2 plus 5x plus constant, and you're done. And you're done. Okay. Are you getting it? Are you understanding it? Shall I move on to the next thing, which is type number 3 of variable separable? I know that this type is actually not, I mean, I to like it obviously, because for first time learners, this type is not that comfortable. But if you will see, if you solve a few problems, then you'll be like, acha, like this kya? Okay, we know. Type 3 is polar coordinates. I know that you guys are, whenever something polar or theta vagera happens in mathematics, you guys are like, calculus mein theta, we don't want it. But understand, this is not that difficult. Just understand the drill, catch of it, you will be fine. Okay. So if you see x dy plus y dx and if you see x dx plus y dy and at the same time you see x dy minus y dx, okay, these type of expression in any differential equation, understand that both are associated with a common thing. X dy plus y, x dx plus y dy is r dr, and x dy minus y dx is r square d theta, guys. Okay, let me tell you that what I'm trying to say. So these two expressions you will get. So whenever you see x dx plus y dy, whenever you see x dy minus y dx, what you have to do is, you have to keep that in mind. Just put x equals to r cos theta, y is equals to r sin theta. Okay, you have to do it. That this thing is you have to do. Now again, I'll just give you the direct results, what you have to remember. Okay, so now if you square and add these two quantities, what will you get? X square plus y square will be equals to what? R square cos square, R square sin square. You take R square common, you will get R square into 1. So this thing you have to remember, x square plus y square is equals to R square. Now you differentiate this, by the way. If you differentiate this, what will you get? 2x dx plus 2y dy is equals to what? 2x dx plus 2y dy is equals to 2r dr. Can you see this? This is actually the first point. Can you see this and this are same? Right? Okay. And so square and add. So just by this is the main point. Square and add, or second thing what you can do is divide. So tan theta will be equals to y by x. Now differentiate this. If you differentiate this, tan theta is what? Sec square theta d theta is equals to x square x dy minus y dx. Correct? Sec square theta. Now tell me, from here cos theta is x by r, sec theta is r by x. So r by x whole square. Correct? And this x square will go here. So this is x square d theta is equals to x dy minus y dx. Can you see x square gone? So now this is r square d theta is equals to x dy minus y dx, which is the second thing. Can you see? So basically whenever you see x dx plus y dy together with x dy minus y dx, just put r cos theta x, r sin theta y. Differentiate, you will be done. Okay. Alright. Now like similar to this, you will have two types of the polar coordinates. First one was the moment you see x dx plus y dy. But what if you see x dx minus y dy? What if you see x dy minus y dx again? Basically both negative you see. Okay. So if you see these two things, let me tell you that this is again r dr, this is r square sec theta d theta. Okay. How will you do this? So in this substitution is x equals to r sec theta, y is equals to r tan theta. Again same thing you have to do. Just square and subtract, not add, subtract. So x square minus y square this time is going to become 1. Now you differentiate 2x dx minus 2y dy is equals to 2r dr. So can you see? If you do that, you will get this. Okay. And now if you divide this, what will you get? So if you divide this, you are going to get y by x is what? R cancel, tan by sec. Now tan by sec is sin by cos by 1 by cos. So this is sin theta. Now differentiate. So again, x dy minus y dx upon x square is equals to, now derivative of sin is what? Cos theta d theta. Now cos theta will be replaced by sec theta is x by r. So cos theta will be r by x d theta. This is x square x dy minus y dx. Correct? X gone. So this is x dy minus y dx is equals to x into r. Now r is here. What about x? X from here would be r sec theta. So r sec theta d theta. This is your expression. This is actually the second expression. So I have just given you the proof of the second expression. Okay. Now you must be wondering, ma'am, okay, got it, but we are not understanding what is the application. Little we are getting the proof, but we are not understanding like what will be the question and how to apply it. Okay, so you just have to remember the results. Okay, remember the results and the substitution. I'll tell you. So if you see x dx plus y dy is equals to x dy minus y dx. So this is polar coordinates type 1, guys. Polar coordinate type 1. Okay. X dx plus y dy. Let me just go back. So whenever you see x dx plus y dy and x dy minus y dx, use this r cos theta, r sin theta. Okay. Let us come back. So this is r dr. This is your x. X is what? R cos theta. And x dy minus y dx is nothing but r square d theta. Now the moment you will do it, you will get variable separable form. Okay. R cancel. Now it is going to become 1 by r square dr equals to cos theta d theta. Integrate, minus 1 by r equals to, now integration of cos theta is what? Sin theta plus constant. This is your final expression. Now r can be replaced by c. Here x is r cos theta, y is r sin theta, correct? Where r is your square root x square plus y square. So if you want to write the final expression in terms of x and y, this is minus 1 upon square root x square plus y square equals to, now sin theta is y upon r plus c. This is how it is. Sorry, this is y by r, correct? Now again, r is x square plus y square. Okay. This is how you solve such questions. Now one more. Okay. One more question. X plus y dy by dx minus x dy by dx minus y equals to square root of 1 minus x square minus y square upon x square plus y square. Okay, now hold on. Identify that which polar coordinate type is this. So this is x dx plus y dy, type 1 again, upon x dy minus y dx equals to 1 minus x square plus y square upon x square plus y square. Now to solve this, again, this is what r dr upon r square d theta equals to square root 1 minus r square upon r square. This is how it is. Okay. Alright, now this is r and r is getting cancelled out. This is square root of r square. So this r and this r square both will get cancelled out. Dr upon square root 1 minus r square is equals to d theta. Now this integration of this is sine inverse r is equals to theta plus c. Now r is what? So sine inverse square root x square plus y square. Theta is tan inverse y by x plus c. This is your expression. Okay. Alright. So again, now we are successfully done with variable separable and reducible to variable separable. Okay. Before I start homogeneous, let me tell you something about differential equation, right? As a whole. Like the moment you will see any differential equation in JEE main, you will be like, what to do? Many students are not good at differential equation. Many students leave this chapter. You know why? You know what? They look at that question and they don't know what to do. I will tell you what to do. You look at the question in JEE main and you will be like, okay, is this a variable separable form? No. Then reducible to variable separable? No. Then is it polar coordinate? No. Is it homogeneous? No. Is it reducible to homogeneous? No. Is it linear differential equation? Right? So what I'm trying to say is, understand. Basically what I was doing here right now is identify the form, guys. Identify the form. Are you understanding what I'm trying to say? Identify the form of the differential equation. Rule out variable separable, no. Reducible to variable separable? No. Then you will have that clarity, okay, this is homogeneous. No, it's not homogeneous, then it's different, linear differential. It would be one of those forms which you have already studied. You can't just be looking at a differential equation and like looking at differential equation, I don't know what it is. I don't know what to do, how to proceed. You will not be able to do it if you do not do this processing in your brain. This is very important. Important tip of the day. Now, homogeneous differential equation means that a differential equation of the form f of y by x. Okay. Alright, let me just give you one example. For example, y is equals to f of x passing through point 1, 2 is the solution of differential equation 2x square dy equals to 2xy plus y square dx. Then they are asking about f of half equals to what? Now, if you see this differential equation, what will you do? Try separating the variable out. That okay, if I can separate the x terms on the left hand side, y terms on the right hand side, but if you try to do that, it won't happen. Then you think about, okay, is this like dy by dx? Like dy by dx, if you calculate 2xy plus y square upon 2x square, this thing. Can you see dy by dx is not a function of straight line? No, it's not that. Okay, so next what you have to do is take x square common from the numerator and denominator both. If you take x square common, it will become 2 y by x plus y by x whole square upon 1. Okay, so this is your, can you see now dy by dx is actually becoming complete function of y by x, which is a homogeneous differential equation, guys. Yes or no? Homogeneous differential equation, right? So homogeneous differential equation. Now how to solve it, ma'am? Okay, we get it, your dy by dx is becoming y by x. If you separate it out, y by x, or actually twice of y by x plus y by x whole square. What to do but? So in this case, you put y equals to vx, or you can say y by x is equals to v. So now if you do that, this will become, right hand side will become what? 2v plus v square. But what about left hand side? Is it gonna be dy by dx? No. Now you have to differentiate this with respect to x. Dy by dx is equals to, on the right hand side, vx, product rule. V is constant, derivative of x is 1, plus this time x is constant, dv by dx. So dy by dx is equal to v plus x dv by dx. Okay, alright. Now it is gonna become variable separable. See, watch me. X dv by dx is equals to v plus v square. Now dv upon v plus v square is equals to dx by x. Okay, now you have to integrate. How to integrate? Right hand side is pretty easy, log of x plus constant, I'll be doing it. What about left hand side? You have to make it a perfect square. For left hand side, you have to make it perfect square. Let us do it over here. So dv upon, now v plus half whole square minus half okay. So I guess we have done one mistake. If you have noticed, let me go back. 2x square, right? So this is 2. The denominator is not 1, it's 2. So if it is 2, here it will be 2, here it will be 2. Correct? So now we need to correct each and everything. So the question will be a little bit different, like the solution. Okay. So yes, so this is 2 to cancel. So this is going to become what? Dy by dx. Let's convert. So dy by dx is v plus x dv by dx, right? Is equals to v plus v square by 2. Now v is getting cancelled out with v. So we are having dv by v square dx by x, and 2 is adjusted like that. Now integrate. So this is v raised to 1 by v square. So v raised to power minus 2. So this is minus 1 by v. And 2 is already, so minus 2 by v is equals to log x plus c. So this is minus 2 x by y, right? 1 by v is x by y, ln x plus c. And if I go back, are they giving you curve is passing through point 1 comma 2. So minus 2 ln 1 plus c, and this is going to become c equals to minus 1, right? C is minus 1. So now your curve is what? If c is minus 1, then your curve will become minus 2x by y equals to log x minus 1. Okay. All right. And f of half is what they are asking you. So f of half, that means you have to put x equals to half. So the moment you put x equals to half, you will get minus 1 by y equals to ln 1 by 2 minus 1. So it is going to become what? Y equals to 1 minus ln 1 by 2, and it is 1 upon. So 1 minus 1 upon 1 minus ln 1 by 2, and this is going to become y equals to 1 upon 1 plus log 2. So the answer will be, yes, so answer will be what? That's it. Are there any options? No. F of half. Yeah, I guess yes. So this is how your answer would be. Okay. So now, so this was the homogeneous differential equation now. So basically dy by dx will be given in terms of f of y by x. Now I will recommend that you also on your own solve a few problems, and now we'll be jump on to directly towards reducible to variable separable. Okay. Reducible to variable separable. All right. So reducible to variable separable is dy by dx is a function of two different linear expression. Remember, actually same thing we did in, sorry, this is not reducible to variable separable. This is reducible to homogeneous. Okay, homogeneous. Now understand. This same thing we studied, similar thing, not same. We studied in variable separable as well. Remember type 2 of variable separable where dy by dx is like a function of two different straight lines or two different linear expression. But in that case, your like there was a special case. So in that case, b and a, so these two coefficients, sum of these two coefficients should be 0. But here it should not, it is not necessary. Okay. So this is a general case. So reducible to homogeneous. Now, right. So now how to do it? In here you have to put x equals to capital X plus h, y is equals to capital Y plus k, and this h and k will be decided by understanding that the moment you will put these substitution in this equation, what will happen? You will get terms related to capital X, terms related to capital Y, and some constant terms. So the condition is your constant should be 0. Don't worry, we'll do one problem, one sample problem. I'll show you how to do that. So now the question is dy by dx equals to 2x minus y upon 1 plus 1 upon x minus 2y minus 1. Okay. So now Again similar thing, two different linear expressions. So x is equals to capital X plus h, y is equals to capital Y plus k. So if you put, what will happen? 2 capital X plus h minus y plus k plus 1 upon x plus h minus 2 y plus k minus 1. This is your dy by dx. Okay, sorry, this is not dy by dx. Now understand, we have to shift, switch, right? So dx is equals to dx, d capital X, dy will be equals to d capital Y. So that means dy by dx is equals to dy by dx. Both are same. D small y by dx is equals to d capital Y by dx. Are you getting it? Now what I wanted, you just want to know the value of h and k. These are two constant. So now 2x minus y plus 1, can you see, upon x minus 2y minus, sorry, this is, yeah, yes, 1 and plus 2h minus k. Can you see this is a constant, and this is x minus 2y is plus h minus 2k minus 1. Okay, so can you see that again a variable term, but a constant term is also there. Now what is this? What is ma'am trying to say? So ma'am is trying to say that you have to calculate h and k in such a way that the constant term should be 0. So 2h minus k plus 1 is 0. H minus 2k minus 1 is 0. Okay, and now you just multiply 2 over here and then subtract. So 4h, so this is 3h, 2 then plus 3 equals to 0. So h is going to become minus 1. See, have a look. So h is going to become minus 1. And what about k? So k is going to give you minus, okay, k is again minus 1, correct? H minus 1 and k minus 1, yeah, it will make sense. H minus 1, k minus 1, yes. So minus 1 comma minus 1, okay. Anyway, if you put it, so this is 0, this is also 0. So your dy by dx will 2x minus y upon x minus 2y. And now if you take x common from numerator and denominator both, your dy by dx will become 2 minus y by x upon 1 minus 2y by x. Here y by x, now y by x will be substituted as t. So this will become y is equals to tx, dy by dx equals to t plus x dt by dx. Correct? Okay, you can put it as v as well. So yes, now your equation will be what? Tell me. So this is going to become t plus x dt by dx equals to 2 minus t upon 2 plus, sorry, 1 minus 2t. Now again, what you have to do is, again variable separable, let me just go back. So this is x dt by dx is equals to, if I go back, 2 minus t upon 1 minus 2t minus t. Take LCM, 1 minus 2t, 2 minus t minus t plus 2t square. So this is 2t square minus 2t plus 2 upon 1 minus 2t, correct? X dt by dx. T terms. Now 2 you can take common, t square minus t plus 1 is something which you cannot. So this is going to be actually 1 minus 2t upon 2 t square minus t plus 1, and this is dx by x. Now understand, if it is it solving by substitution, if you substitute this as like t square minus t plus 1 as u, 2t minus 1 dt becomes du, right? So this is going to become minus du. So minus du upon 2u is equals to dx upon x integral, and this will give you minus 1 by 2u. So minus 1 by 2 log of u is equals to log of x plus log of c. So this is u power minus half is equals to xc. Okay, u power minus half is equals to xc, and if you do it here, okay, so u, what is u? Tell me. U is t square minus t plus 1 power minus half is equals to x, capital X, C. Now what is t? Let me just go back. Y by x is t. So y square by x square minus y by x plus 1 minus half is equals to xc. Okay, y square minus yx plus 1 raised to power minus half, and this is going to become x raised to power minus half, x square raised to power minus x raised to power minus 1. So this is equals to c. Okay, so yeah, this is y square, capital Y square. So your final answer, if I just go back, y square minus yx plus 1, is it plus 1 or not? Not, plus 1 x square. Yes, this is x square, capital X square raised to power minus half equals to constant. Or you can say that square root of y square minus yx plus x square is equals to constant. Or you can just square it and add another constant. So you will get y square minus yx plus x square is equals to some constant k or k naught, whatever. Now y is what? Y and capital X. Can you see h and k are minus 1? So capital X is x minus 1 and y minus 1. So here y minus 1 square minus y minus 1 x minus 1 plus x minus 1 whole square is equals to k naught. So this will be your answer. So answer will be like this. Okay. Hold on. Give me a moment. Yeah. Okay. Yes. Now, so homogeneous, reducible to homogeneous, done and dusted. And now the last third form, which is linear and very important, linear differential equation. Short question from this. Short question from this. Okay, short question from this. Okay, so now your linear differential equation of nth order looks like what? An x, function of x basically, dny upon dx raised to power n plus an minus 1 x dn minus 1 y upon dx n minus 1, and this will go all the way up to a1 x, and this is dy by dx plus a naught of x is equals to function of x. This is what your nth order differential equation will look like. Okay, but in our syllabus, the good news is we have a very simple linear differential equation. So it is of order 1. So if it is of order 1, this term, everything else is cancelled out. So can you see? It is going to be just this part. So of order 1, linear differential equation of order 1 will look like dy by dx plus py equals to q, where p and q both are function of x. Okay, let me give you a few samples so that you understand. Like, form identification is the key in differential equation, right? I have already told you multiple times. Form identification is the key. So y dy by dx equals to x square y plus x cube. Now you know dy by dx plus py equals to q, where p and q are function of x. So now you have to calculate dy by dx, and it is going to become x square plus x by y. So no, this is not at all a linear differential equation because the form is incorrect. See, although order is 1, but the thing is it should be py is equals to q. So this x by y is not correct. Okay, and yeah, second is x raised to power 4 dy by dx equals to xy plus 5. Is it a linear differential equation directly? So dy by dx is equals to 1 upon x power 4 y, this is x cube, plus 5 by x power 4. So understand, now this is, yes, dy by dx, if you shift this towards left hand side, this will be function of x, y, and this on the right hand side clearly function of x. Okay, so these two forms are absolutely matching with each other, right? Are you getting my point? Then let me just give you the third scenario, x d2y by dx square. Come on, this is not at all a linear differential equation of order 1. This is not a linear differential equation of order 1, although it's a linear differential equation because the degree, can you see degree of d2y by dx square and dy by dx is 1. So here the linear term doesn't mean order 1. Linear differential equation means every differential coefficient will have degree 1. Now in our syllabus, linear differential equation, that means degree should be 1, but order should also be 1. So degree 1, order 1 linear differential equation is this. Okay, so this is not at all a linear differential equation of order 1. Okay, alright, so now linear differential equation of order 1, I already told you LDE of order 1. Degree 1 is covered by the term linear. Linear itself tells that I am the degree 1, but order 1 we have to specify. That's in our syllabus. Okay, so dy by dx plus py equals to q. Okay, so this is how it is. Now understand, the best part about linear differential equation is that you don't have to solve it. We have already solved it for you. You just have to apply the direct formula. What is the formula? Now to apply the formula, we have to first of all figure out the integrating factor. Okay, what is integrating factor? E raised to power integral of p dx. Okay, once you figure out this integrating factor, now you have to remember the final solution formula, which is y multiply integrating factor is equals to integral of q multiply integrating factor with respect to dx plus constant. This is what you have to keep in mind or remember. You don't have to like solve it. Calculate integrating factor, fitting, just the fitting will happen. Okay, alright. Now let me just give you some problems. So question is from JEE Main 2021, guys. Yes, JEE Main 2021. So question says y is equals to y1 be the solution of y equals to y of x. B, the solution of cosec square x dy plus 2 dx. Hold on. Cosec square x dy equals to, plus 2 dx is equals to 1 plus y cos 2x, and here you are having cosec square x dx. Okay, so this is a differential equation which is given to you, and they are saying y of pi by 4 is given as 0. What they are asking is y of 0 plus 1 whole square is what, and the options are also given to you. Root e, 1 upon root e, 1 by e, and e. Okay, alright. So now understand that, see, now you have studied a lot of problems. So you have studied variable, separable. So the moment you will see the equation, you will be like, okay, am I able to separate out the y terms and x terms? But I am not able to do that. No, we are not able to do that. If you try to separate out y terms, it will not happen in this question. Okay, alright. Next is again that dy by dx is not a function of straight line, neither function of two lines. It is not like polar coordinate form. It is not looking like that, right? Then we have homogeneous. It is not looking like homogeneous as well. It is quite intuitive and you can check it out. So the last option is linear differential equation. Again, for that dy by dx should be calculated. So now understand how to calculate dy by dx. So dy, can you see the only term is over here is this dy. So dy will be kept over here. Rest everything will shift it towards the right hand side. Cos x square x dy will stay here. Rest everything. So this is 1 plus y cos 2x. This is then cos 2x cosec square x minus 2 and dx. Correct or not? Tell me. Yes. So this is going to become, if we further simplify it, cosec square x, hold on, cosec square x dy. Now 1 plus y cos 2x. Understand what I'm trying to say. This is cosec square x. Hold on. Equals to cosec square x multiply cosec square x plus now y cos 2x. So y cos 2x. Now you know what? Cos 2x is what? So you know what? 1 minus cos 2x is 2 sin square x. So cos 2x would be 2 sin square x minus, sorry, cos 2x is what? 1 minus 2 sin square x. Remember that formula? So just put it over here. Y 1 minus 2 sin square x. Then we are having cosec square x outside and we are having minus 2 as well, bracket close dx. So what I did is, let me tell you, 1 multiply cosec square x, then y cos 2x. So this is cos 2x. So y cos 2x will be multiplied by cosec square x and this is done. So now cosec square x dy will be kept over here. This is again cosec square x dx, correct, plus y cosec square x and this is minus 2y. Now sin square cosec square is 1 and this is minus 2 and this is all dx, correct, not dy, dx. Now dy by dx, now just shift it out. Okay, what I'll be doing is cosec square x, I'll be shifting it towards the right hand side. So this is going to become what? Dx is outside already. So this is cosec square by cosec square is 1 plus y by cosec square same minus 2 y plus 1 and you are having sin square x and yes, this is dx. No, dx is already gone. Yes, so this is it. Right, now one more thing. Now can you see dy by dx is coming out as, if you take 1 by y, 1 plus y common, what will you get? You will get 1 minus 2 sin square x. Yes, 1 minus 2 sin square x. Are we going right? Are we doing good? Hold on, let me just check. Hold on. Have I done any mistake? Let me just do it one more time, okay? Let us do it one more time, huh? Let us cross check. So it was cosec square x dy plus 2 dx equals to 1 plus y cos 2x, correct? Cosec square x dx. Okay. What we can do is, right away we can do one thing, we can divide it by cosec square x. So this is dy plus 2 sin square x dx equals to 1 plus y cos 2x and that's it. This is dx, correct? So what we can do is we can divide it by dx. So this is dy by dx plus 2 sin square x is equals to 1 plus y cos 2x, correct? Is it like this? Okay. And now dy by dx will be equals to minus, okay, dy by dx minus y cos 2x. Yes, this can be done like this. Minus y cos 2x and 2 sin square x will go over here. So minus 1 minus 2 sin square x. Correct? Okay. Now this is, can you see, dy by dx plus py equals to q, where p and q are function of x. So can you see, p over here is minus cos 2x and q is 1 minus 2 sin square x, which is again cos 2x. Correct? Okay. Now what we need to do is apply the formula. So how to solve it? Y multiply integrating factor. What is integrating factor? Integrating factor is e raised to power integral of. Let's first calculate integrating factor, then talk about anything else. Integrating factor is e raised to power minus p dx. So cos 2x dx integral. So integral of cos is what? Sine. So e raised to power minus sine 2x by 2 is your integrating factor. Now your answer would be y multiply e raised to power minus sine 2x upon 2 is equal to integral of, and here it would be, so y multiply integrating factor, integration of q integrating factor. What is q? Cos 2x, then integrating factor dx plus c. Now you have to just integrate this part. How to do that? For that, just put this thing, you put add as t. So if you put this thing as t, so differentiation of sine is what? Cos. So this is minus cos 2x and differentiation, and then we have 2, 1 by 2 was already there. So minus cos 2x dx will become dt. Correct? So cos 2x dx. So y e raised to power minus sine 2x by 2 is equals to, now this is negative of integral of cos 2x, this is going to be dt e raised to power t plus c. So y e raised to power minus sine 2x upon 2 equals to, this is e raised to power t only, that means e raised to power minus sine 2x by 2 plus constant. This is your curve, right? This is your curve. And now what they are saying is y of pi by 4 is 0. So put x equals to pi by 4. X equals to pi by 4, y you will get 0. Let's do that. So if y is 0, left hand side is 0, x is pi by 4, so e raised to power minus 1 by 2 is your plus c. Correct? So, and this is by the way negative. So basically c is root e. So your c is coming out as, if you c is root e. Correct? So your expression is y e raised to power minus sine 2x by 2 is equals to e raised to power minus sine 2x by 2. Let me just go back, plus c, which is plus root e. Okay. And now what they are looking for is, they are looking for y of 0 plus 1. See what they are looking for. Let me just go back. Y of 0 plus 1. So this I am cancelling out. Y of 0 plus 1 whole square. Correct? So y of 0, that means you have to put x equals to 0. So the moment you put x equals to 0 here, you will get y. X is 0. So e raised to power 0 is 1 equals to again 1 plus root e. So y of 0, sorry, this is negative. This is negative. So y plus 1 is equals to root e. Y plus 1 whole square is equals to e. So your answer would be just e. So e is the correct answer. Option D is absolutely right. This was asked in JEE Main 2021, by the way, guys. So yeah, that was it. Okay. All right. Shall we do one more problem? One more problem on this. I know that that you will not feel confident if you not do enough problems on this. Linear differential equation is absolutely important. Now one more question, y square minus x dy by dx equals to 1, guys. where y of 0 they have given as 1. Now they say the curve intersect x-axis at point whose abscissa is. Options are 2 minus e, minus e, 2, 2 plus e. Okay, all right, yes. So now just understand the same thing I am gonna tell you. Whenever you see differential equation question, na, start like finding out which form is this. Is this variable separable? No, it is quite evident. You can't separate x and y right away, right now. Reducible to variable separable? No, because reducible to variable separable says dy by dx should be linear function of linear function basically. It is not linear. Y square minus x, come on, it's not linear right now. Okay, ruled out. Then homogeneous, so dy by dx, you can see dy by dx is not at all coming out as, it is y square minus x. It is not coming out as function of y by x. Even if you take x square common or x common. Then reducible to homogeneous means dy by dx should be function of two different straight lines or linear expression. No, not at all. Linear differential equation, it is not looking like. So what is this? Ma'am, what is this? Everything is ruled out. Now, see this thing a little differently. Remember that LDE in y basically. LDE in y. So this is dy by dx plus py is equals to q is a thing, right? Where p and q are function of x. Okay, ma'am. Now, can we say that dx by dy plus px is equals to q, where p and q this time are function of y, is also a linear differential equation, just x and y are interchanged? Yes. So just check it out. This is also a thing and this is actually important in NTA, for NTA. dx by dy is equals to y square minus x, correct? Now what are you looking for? This is dx by dy plus px. So dx by dy plus x equals to y square. This is 1. Okay. So px is equals to y square. So can you see p is 1? P is 1. And q is what? Y square. So p here is 1, q here is y square. And now like similarity will be there, but the terms will be interchanged. See. So now integrating factor will become what? E raised to power integral of p dy. So e raised to power integral of 1 dy. E raised to power y is your integrating factor. And your solution will be not y integrating factor. It would be x multiply integrating factor equals to integral of q. Here q is y square into integrating factor dy plus c. This is how it is going to become. Okay, now you have to just integrate this. You have to integrate this. Okay. Now I have told you the shortcut to integrate such questions. Y square e raised to power y. How will you tackle this? First of all, y square is kept constant. And then, so plus y square. Now it is differentiated with a negative sign minus 2y. Then it is differentiated one more time, but this time with a positive sign, so plus 2, correct? Okay, and now what about, so this is y square. Now what about e raised to power y? E raised to power y is integrated here, then it is one more time integrated here, then it is one more time integrated here. So it is making like same thing. So x e raised to power y is equals to y square e power y minus 2y e raised to power y plus 2 e raised to power y plus c. Although you can apply by parts, but you have to apply multiple times to get the result. But this is the answer. So yeah, this is your correct thing. Have a look. Let me know. Okay. All right, guys. I guess that now we'll be moving towards reducible to linear differential equation. Reducible to LDE, guys. Reducible to linear differential equation, okay? So reducible to linear differential equation where dy by dx equals to xy plus x cube y square. Here what will happen? You will get your dy by dx in such a way that dy by dx is equals to, this will be fine, but can you see the extra power of y will be there? How to tackle it? So first of all, extra power of y, the moment you will see, divide by y square. If it is y cube, then you have to divide by y cube. Divide it by y square. dy by dx 1 by y square equals to x by y plus x cube, correct? Okay. So now 1 upon y. Can you see 1 upon y? So this 1 upon y will be substituted as t. So that minus 1 upon y square dy by dx will become what? Dt by dx, correct? So this is minus dt by dx equals to x t plus x cube. Are you getting it? So now you will see a linear differential equation in t, not in y. So see, dt by dx, see, if you shift this over the right hand side, you will get dt by dx plus xt is equals to minus x cube. Now can you see? dy by dx plus p, dy by dx plus py equals to q. Here, so basically, if you compare it with the original, dy by dx plus py equals to q, where p and q are function of x. It is matching, just y is replaced by t over here. So now integrating factor will be, so this is your p, right? P, and this is your q. P and q both are function of x. So e raised to power integral of x dx is your integrating factor. So this is e raised to power x square by 2. This is your integrating factor. Now your answer will be t multiply integrating factor is equals to integral of q. What is q? Minus x cube e raised to power x square by 2 dx plus c. Now you have to integrate this. Okay. So understand. See. Now x square by 2 I am putting it as v. So x dx will become dv. Correct or not? So this is t e raised to power x square by 2 as it is. On the right hand side, can you see x square by 2 is v, or you can say x square is 2v. So what I'll be doing is, understand, minus sign is here. Then you have x square e raised to power x square by 2 and x dx plus c. Let me just show you what I'm doing. So x cube, I have written, this x cube will be treated as x cube x square into x. Can I do that? Definitely. Why I am doing that? Because x dx will be substituted as dv and x square is 2v and this is e raised to power x square is e raised to power v, right? Integral negative sign and plus c. This is so t e raised to power x square by 2. T e raised to power x square by 2 is equals to now minus 2. Integrate v e raised to power v. How will you integrate v e raised to power v? So you can just apply that, what do we call? V e raised to power v, right? So first function by parts will be applicable. First function is constant, integration of second minus integral of derivative of first, so e raised to power v, basically it is going to be this. Yeah, now start plugging in and you'll get your answer. So t is what? 1 by y. So e raised to power x square by 2 upon y is equals to minus 2. V is what? X square by 2. X square by 2 e raised to power x square by 2 minus e raised to power x square by 2 plus c. So this is how it is going to be. This is your final answer. Have a look. Let me know. And after that, we'll be doing one more question and then we have a small more type which is exact differential equation. Okay. So let me just solve the next question, which is y equals to y of x gives you, so y is equals to y of x is solution of 2xy square minus y dx plus x dy. Yeah, so before I just start solving it, let me just tell you what I have in my mind. So yes, sometimes what happens is, if linear differential equation doesn't work out, try finding dx by dy type linear differential equation. If that doesn't work out, so your last option will be, sometimes they can give you reducible to linear differential equation. I know that identifying that is a little bit different, but you just try ruling out that it is not that, it is not that, then there will be like one or two choices will be left. Now you have to pick between the two, that okay, is it linear differential or reducible to linear differential, like that. Elimination, basically any elimination of form should be done for difficult forms especially. Okay, now this question, y is equals to yx is the solution of this differential equation, and it passes through intersection of lines 2x minus 3y equals to 1 and 3x plus 2y equals to 3. Then they are asking y of 1 equals to what? Okay, I'll be giving you this as homework. So understand that this, identify the form. Let me just help you in identification of form. So this is 2xy square minus y and dx plus x dy. I don't know right now which form is this. I don't know, honestly. So dy by dx, let's start calculating dy by dx. So see, 2xy square minus y dx will become minus x dy. Correct? Now this dx will go here, minus x dy by dx. This is 2xy square minus y. Correct? And this is minus x. 2xy square minus y upon minus x is equals to dy upon dx. Okay, and now this minus sign, if it will go up, y minus 2xy square upon x is equals to dy upon dx, guys. Okay, understand. Now separate it out. So your dy by dx is coming out as what? Y by x minus 2y square. Okay, so this is how it is. Dy by dx is coming out as y by x. Now see, dy by dx minus y by x is equals to minus 2y square. See what is happening. See what is happening. Now it looks like it is a linear differential equation, but something is wrong over here. What is wrong? Understand what is wrong over here. So dy by dx plus py. So p is fine. P is minus 1 by x. Y is equals to q. Now q should be function of x, which is not coming. This y square is something which is bothering us. So we need to divide. This is actually reducible to. This is reducible to LDE. Now divide by reducible to linear. Divide by y square. So 1 by y square dy by dx minus this will be 1 upon xy equals to minus 2. Now you have to put 1 by y equals to t minus 1 by y square dy by dx will give you dt by dx. So this is minus dt by dx minus 1 by x t equals to minus 2. Cancel, cancel, cancel. Dt by dx plus t by x is equals to 2. Now this is a linear differential equation, right? Because the original one is what? Dy by dx plus py equals to q, where p and q are function of x. P and q, right? So here p and q. So p is 1 by x and q is 2, just 2, right? P is 1 by x, q is just 2, and you just have to, integrating factor will be e raised to power integral of 1 by x dx. So this is e raised to power ln x will be x, just x. Correct? Okay. So now, yes, the solution will be t multiply integrating factor equals to integral of 2 multiply integrating factor plus c, and this is going to become tx equals to x square plus c, and guys, we are okay. Yes, so now I will leave that up to you. Now I will not be solving. So t is what you know. T is 1 by y, correct? Yes. So x by y equals to x square plus c. Now you have to solve these two equations to get the initial condition. What is initial condition? That means that point that it is passing through. So curve is passing through intersection point of these two lines. So basically this, if you solve these two lines, you will get a point. You have to satisfy that point in this equation to get the value of c. Once you get the value of c, now you have your curve, and what they are asking is y of 1. You put x equals to 1, you get the value of y, and you're done. Okay. Alright. Now the last part is exact differential equation. Okay, exact differential equation. Okay, now what is exact differential equation? This is my favorite type, by the way, because this is quite intuitive. You'll find very intuitive if you understand these small basics of integration and differentiation. So first, x dy plus y dx is what? Remember, I told you this, x dy plus y dx. Don't you think somebody has kept x constant, differentiated y, plus y constant, differentiated x? So that means somebody has applied product rule in x multiply y. So this is like d of xy. And if you want to integrate it both the sides, now this will become xy. Okay. Second, y dx minus x dy upon y square. The moment you see this, don't you think somebody has used quotient rule of derivative that says that d of x by y. If you want to differentiate this is the second function. So second function square, second function constant, derivative of first minus first function constant, derivative of second. Okay. Alright. Now third, d of x plus d of y upon x plus y. Don't you think that if I take d side, this is dx plus y upon x plus y. So don't you think, remember, dx by x is what? Dx by x is what? ln x. So this is what? D of ln x. Sorry, d of ln x plus y. Derivative of ln x plus y is what? 1 upon x plus y, and then differentiation of x plus y. So basically what are you doing is reverse of, so you are doing the integration only basically. Okay. Now y dx minus x dy upon xy. What is this, ma'am? It looks like it is a quotient rule, but it is not. Because in quotient rule, you will need y square over here. So what we will be doing is, we'll be keeping a y over here. So I'll be multiplying y, I'll be dividing it by y. Sorry, this is y by y. So it will become what? Y dx minus x dy upon y square upon, can you see this x will go over here, y by x. Not y by x, this is going to become x by y, correct? X by y. X by y. Okay. So this is going to become what? So this is d of x by y upon x by y. So this is what? D ln x by y. Don't you think? This is d ln x by y. Yes. Alright, so this is it. Now next is fifth. X dy minus y dx upon x square. Now again, this is a quotient rule, but this time x is in denominator. So this is d of y by x. Sixth, now similarly, x dy plus y dx upon xy is there. So what is x dy plus y dx, ma'am? It is dxy upon xy. Right? Remember we did it. Now what is this? D of, ma'am, ln xy. Understanding? Next, it is, seventh is x dy minus y dx upon xy. Okay, again, if it is a negative sign, we know that it's a quotient rule. But this is x dy, so I need one more x over here and one more x over here. So this is what? See, x square will be there and this is upon x by y. So this is d of y by x, not x by y, this is y by x, correct? Upon y by x. So this is d of ln y by x, just the reverse of the previous one. And then we are having, okay, one more thing, which is x dy minus y dx upon x square plus y square. Now this is something a little bit on trickier side. See, again, we have x dy minus y dx. So what we need is x dy minus y dx. I need x square upon, I need one more x square. So this is 1 plus y square by x square. So what I did is, I just divided both numerator and denominator by x square. If you divide it by x square, you will get this. If you divide the denominator by x square, it will become x square by x square 1, y square by x square 1. Okay, so this is your, what about this? This is d of y by x, d of y by x upon 1 plus y by x whole square. So can you see what is this? Let me just remind you about this formula. Dx upon 1 plus x square integral is what? Tan inverse x. So don't you think it's a similar type? D something upon 1 plus something square. So this is tan inverse y by x and this is d. Because right now we are not integrating. D is there. We are just on the verge of integrating. So these are the forms, intuitive forms. Exact form, I call it as an intuitive form. Okay. Now let me just give you again similar thing, which is the number 8th, 9th. Now you start telling me y dy minus x dx upon x square plus y square. Sorry, this is y dx. Yes, y dx minus x dy upon x square plus y square. So this time what will happen? I will be dividing it by y square and by y square. So what I'm gonna get is, this thing will become what? Tell me. So this is d of x by y upon 1 plus x by y whole square. So this is tan inverse x by y. Same thing, but the x and y are getting interchanged. Now the next thing, x dx plus y dy upon x square plus y square. Now hold on. See, be very mindful about what is written. Okay, x dx plus y dy, let me just tell you. See, x dx plus y dy is completely different from x dy plus y dx. Okay, this is product rule. X dy cross. This is not product rule. X dx. X dx is not product rule. This is something new. Don't get confused. Don't mix up. So we have to observe carefully exactly what is written. Is it x dx? Then it is not a product rule. Is it x dy? Then it is a product or quotient rule. Cross connection is a product or quotient rule, right? Now x dx plus y dy. Understand? If I just multiply 2 and 2 over here, so don't you think this numerator is derivative of x square plus y square? Differentiate, try differentiating only the numerator part. So numerator is dx square plus y square. If you differentiate this, it will become 2x dx, 2y dy. Can you see? That is why I have multiplied it 2 upon 2x square plus y square. Now again, can you see d of something upon something? Dx by x integration, right? This is log x. So this is 1 by 2 will be kept. Log x square plus y square. Let's not forget d over here. Okay, then we have 11th, d of minus 1 upon xy. Okay, if this is given, then just start, like this is the reverse thing, by the way. You differentiate. Okay, so d of minus 1 by xy will be what? Minus 1 by x. So this is minus 1 upon xy plus 1 upon plus 1 upon xy square. Then you differentiate. Okay, so derivative. Basically what I'm trying to do is derivative of 1 by x is what? Tell me. Minus 1 by x. So this is 1 by x square and differentiate the x. So dx. Right or wrong? Now we are going to differentiate d of xy. So this is 1 upon xy whole square. And differentiation of xy will be what? Dx plus product rule. Dx plus dxy, right? So it is going to become x dy plus y dx, product rule. Yes or no? So this is how you find out the reverse as well, reverse technique. Okay, and yes, I guess we are done with today's class. My exact differential, just the last question on exact differential I would like to give you, like how exactly you're going to get the question. Y 1 plus xy dx is equals to x dy. This is the question, guys. This is the question. Okay, y 1 plus xy dx is equals to x dy. Now this is the solution, like this differential equation correspond to y is equals to fx, and this curve passes through 1 comma minus 1. Okay, now f of minus half is equals to what? So option A is 2 by 5, option B is 4 by 5, option C is minus 2 by 5, option D is minus 4 by 5. Okay, and if you solve it out, okay, so first of all understand, multiply it, y dx plus xy square dx equals to x dy. Okay, so now what I'll be doing is I'll be shifting this y dx towards the right hand side. Xy square dx equals to x dy minus y dx. And now can you see this y square can be put over here. So this is x dx, which is absolutely fine. The left hand side is sorted, but the right hand side have a slightly different thing. Basically, if you have y square in the denominator now, then you should have y dx over here. So minus sign you come out. So now it is fine, y dx minus x dy. This formula is fitting in. So this is minus of d of x by y, and this is what? X dx. If you integrate, this is x dx. If you integrate both the sides, what will you get? Tell me. So if you integrate both the sides, you will get x square by 2 is equals to minus x by y plus c. This is your final answer. And but you have to put minus 1 comma 1 over here. 1 comma minus 1. 1 by 2 is equals to 1 plus c. C will be minus half. Now you put minus half over here. So it will become x square by 2 plus x by y plus half equals to 0. This is your final solution. Okay. All right. With this, we are done and dusted with today's session. And if you guys are having any doubts, now you'll be needing PDF. For PDF, you have to join the Telegram. So I'll be sharing the PDF in my Telegram, t.me/Namrata Jaisinghani. Just take the PDF, okay, from here, or you can access Jungle Book first thing. So, and also if you are having any doubts, any confusion, any questions, academic, non-academic, anything, ping me here, I will reply you. Okay, all right. Now on this note, this is your Ninja Ma'am signing off, and I'll see you in the next video.